In the previous video, we were discussing about differentiation on trigonometric functions, the basic formulas. Now, let's discuss about few examples on this type. So, the first sum which we are going to discuss is differentiate 2 cos x minus 6 secant x plus 3. Let's differentiate. So, we are going to work on the solutions now. First sum, we are going to differentiate d by dx of 2 cos x minus 6 secant x plus 3. So this is a polynomial function. We are having 3 terms. In this case, all the 3 terms has to be differentiated individually. Okay, so since this is the first sum we are discussing, let me do it to each case. So this is d by dx of 2 cos x, then d by dx of 6 secant x plus d by dx of 3. Okay, now let's differentiate. So now this is 2 cos x, the constant, that is the coefficient, leave it undisturbed. Differentiate the trigonometric function cos x. So the differentiation of cos x, it is minus sin x. That's it. Minus this coefficient constant, have it as it is. Differentiate secant x, d by dx of secant x. When you differentiate this is nothing but secant x tan x. Then the derivative of a constant term is 0. That's it. So we are done with this. Okay. So let's simplify. This is minus 2 sin x minus 6 secant x tan x. That's it. Next sum, second subdivision, 10 tan z minus 2 cot z. We are going to differentiate with respect to z here. So d by dz. Again, this is a polynomial. We are going to differentiate 2 terms here. So need not write this step. Let's proceed directly. First, we are going to differentiate 10 tan z. So have the coefficient 10 as it is. Differentiate tan z. So the formula to differentiate tan z, that is differentiation of tan z, it is going to be secant square z minus this term we are going to differentiate. This coefficient, keep it as it is. Now differentiate cot z. So when we differentiate cot z, it is going to be minus cosecant square z. That's it. So this is 10 secant square z minus into minus plus 2 cosecant square z. That's it. Okay, simple. Third sum, t cube minus t square sin t. So we are going to differentiate with respect to t here. T cube minus t square sin t. Okay, again it is a polynomial. Each term must be differentiated. Now see, t cube minus t square sin t. So first differentiate t cube, children. This will be 3t square. That is x power n, in the sense n x power n minus 1, right? The same pattern. 3 into t power 3 minus 1, that is 2. 3t square minus this is t square sin t. So we need to differentiate t square into sin t. Product of 2 terms. So of course we are going to apply the product rule here. That is, let us have t square as it is. Differentiate sin t. Derivative of sin t, it is cos t plus. Now have sin t as it is and differentiate t square, that is 2t. So what have we done here? So I hope you people remember, when we are going to find out the derivative, okay, if we have like d by dx of, that's nothing but uv. So this is nothing but we'll have the derivative, that is the first term as it is, and find out the derivative of the second term. Then we will have the second term as it is and find out the derivative of the first term. So that only we have done here. Okay, that is, we have kept the first term t square as it is and we have identified the derivative of the second term. Then we have kept the second term as it is and we have identified the derivative of the first term. That's it. Now let's proceed. This is 3t square. Take the minus sign inside. Minus t square cos t. Take the negative sign inside. So this becomes minus sine t 2t, which is nothing but 3t square minus t square cos t minus 2t sin t, and this will not be sin 2t square. That's not like that. This is a constant term, or this is going to be a coefficient which has to be put in the front. That's it. Last sum, fourth subdivision. This is d by dw of tan w into secant w. Okay, so again product of two terms. In that case, what will be done is, we will be having, that is capital D indicates d by dx, like that. uv, that is two terms, product of two terms. Let's have the first term as it is. We will find out the derivative of the second term. Then let's have the second term as it is and find out the derivative of the first term. That's it. So this will be d by dw of, let's have tan w as it is. Find out the derivative of secant w. That's going to be secant w tan w, right? Plus have secant w as it is. Find out the derivative of tan w. So derivative of tan w will be secant square w. That's it. Okay. The derivative work is over. Now let's simplify. Tan w into tan w, tan square w, secant w plus secant w into secant square w, that is secant cube w. That's it. Okay. Thank you.